Okay, this is going to be 6.5, okay? Okay, here's the thing. Okay, you're going to write, first section of examples, write a compound inequality that represents the phrase, okay? Okay, first off it says, example 1, all real numbers between -7 and 27. Here's what you do. You're going to pick a variable, I'll use x. You put the maximum right there, 27, you put the minimum before it. You're going to have x in the middle, okay? Here's how you arrange the inequality symbols. These are called compound inequalities, 27 is your maximum. The sign has to always open towards the maximum. Now it can be equal to it as well. Then go between your x and your -7. -7 is your minimum, so the sign should not open up towards that ever if it's the smallest number. So then it opens towards x. It could be equal as well, and that's all you do. Okay. Now let's prove why that's correct. Pick a number between -7 and 27. Let's pick 4 or 5. Between here and here, does it open to the bigger number? It does. Between here and here, does it open toward the bigger number? It does. Okay, so that's why the signs are arranged that way. Okay, example 2. Temperatures between 30 degrees and 80 degrees. Okay, so you can use any variable you want. I'll use t. If you want to use x each time, that's fine. So you got 30 as the minimum, 80 as the maximum. You're going to put the signs the same way, okay? And again, I will illustrate why that is correct. Let's pick 50 for t. That's between them. So opens to 30, between 30 and 50, between 50 and 80 opens to 80, okay? So that's correct. Example 3. Area between 200 square feet and 900 square feet. Okay, so use A for area, put your minimum here, put your maximum here. So this is your maximum, that's bigger than anything. This is never, the A is bigger than the 200, so there, okay. So that'd be anything in between there, and I've illustrated why if you want to continue to make sure it's right, okay. Example 4, prices between $18 and $75, okay. So let's use P for prices, put your 18 on this side, put your 75 on this side. Well, 75 is the biggest it ever gets, so anything has to open, a sign has to open to 75. Then P is bigger than the 18, so there you go. That's really all that is. Okay, now the next one, if you're on virtual, the next set of examples, you're going to need to draw the number lines because it says write an inequality that the graph represents. These are the graphs, okay? Okay, it's pretty much what you just did. When they're, so you see some of them are combined together between, some of them are on the outsides, okay? And you probably on this assignment, actually you will want to find that sheet that says what direction the graph goes as far as the sign, like what it opens towards. So yeah, here it is. opens towards, what it doesn't open towards. Okay, now the ones that are go between, you should not need this sheet, okay? It's like you did on the last one. You're going to pick x for your variable, you're going to put -2 here, you're going to put 6 here. Okay, then you will open the sign to the 6, because that's the biggest number, and then you need to open the sign to the x, okay? You're not going to put the lines because the circles aren't filled in. That's your answer. Okay, let's prove why it's right. Let's put a 3 for x. Between these two, it should open towards 3. Between these two, it should open towards 6, so that makes sense. Now, what happens when the graphs go apart like that? That means that x can be any number this way or this way. So you write the word or in the middle. It's called an or graph. And you put x here and x here. You do it separately. Then you put 10. Going that way would eat the variable, the letter. When we go this way, we eat the number. Okay, now if you want to test, see if those are right, pick a number that way, but just put it here. Okay, let's pick -50. -4 is a higher value, that's correct. Okay, let's pick 15. So 15 greater than 10, that's correct. Okay, so again, that's your two basic compound inequalities. Okay, it's between the numbers, so x just one time, it's all one line, so x, put the minimum and the maximum. You open the sign towards 16, then you open the sign towards x. You'll underline each one. Again, if you want to pick a number in between and see if it makes sense for x, that will be my guess. Okay, and then these go apart, so that's or. So you put x on each line, and you put 12. That way would eat our variable, or letter, okay? Variable means letter. Put your 7 going this way would open or eat towards a number. Okay. With the line, if it's filled in, the bubble's filled in, you put the equals to. That's what that stands for, okay? Now, when I'm done with the video, you virtual people need to view the problems on 3, 4, and 5, okay? Alright, now the next part, we're going to make the 8 boxes of doom. And the directions now are to solve and graph the inequality. You need 4 boxes for each problem. These are compound. So you have 7 less than or equal to x plus 6 less than or equal to 12. Okay, circle the inequality. You notice how there's 2 of them in the same problem? Yeah, you're going to make your number line, but you need to make a little table under the line. Okay, a table. That's why you need the 4 boxes, because you need to write 2 separate inequalities and solve them, and then put them on the number line. So the first thing, here's the first inequality, the less than. You're going to have 7 and then x plus 6. 7 less than or equal to x plus 6. Then, on the other one, you're going to do an overlapping circle, and you're going to put x plus 6 less than or equal to 12. Okay, now solve each one separately. So x is on this side, no multiplying or dividing, just the plus 6. So get your 6 to 0. So you just need to minus 6. 7 minus 6 is 1. Now the x is behind the symbol, you keep it there. Okay. Now over here, what operations you got? Just a plus 6, no times, no divides, so we just got to get the 6 to a 0. So we have x and 6. Now plot those numbers on the line. Put a 1, put a 6. They can both be positive, that's fine. Circle both of them, you're filling both in. Now this is opening towards the x. I know it's a less than sign, but it's opening towards the x. So it goes this way. Remember, when it opens towards our variable, it goes that way. Never change, doesn't ever change. Here it's opening towards our number, so it goes back, so it's going to go this way. what's going to happen? They're going to combine into each other. Now to label it, you put x in the middle, the 1, the 6. Open the sign to that, and then open to the x. Okay, and that's what that represents. So x can be any number. If I put a 4 for x, 1 and 4 would eat the 4, good. 4 and 6 would eat the 6. Okay, so that's how we do that. So I've solved it. I found these are range problems. Okay, next one. We got -3 less than or equal to x minus 4 less than -1. So you have two symbols. That means it's a compound. There's two solvings you have to make. Okay, so on one side I put -3 less than or equal to x minus 4. So that's the first one. Then the second one, I do a circle overlap with the less than. I've got x minus 4, -1. That should be, this middle part should be included in both sides. It comes second here and then first here. Okay, let's solve them. X is on that side. You got what operation? You got just a -4. Let's make it a plus, negative. So we just circle the x. So you won't have to switch the sign. Okay. We don't even have to think about switching it if there's not even multiplication or division. So you have x behind the symbol. -3 plus 4 is 1. Okay, now on the next one. Same thing, just circle the x, so you don't have to worry about switching the sign. There's no multiplying or dividing I have to do. So +4, +4. So you got x, -1 plus 4 is 3. So 1 and 3. Give yourself some space though. Okay. So circle. You're going to circle there, but you're not going to fill it in. Now with the 1, it's opening towards the variable, so it goes this way. With the 3, it's opening towards the number, so it goes this way. So how do I label that? Well, I put x, you put 1, you put 3. So we open the sign to the 3, then you open the sign to the x. Put the equals to bar there, but not there. And that's it. Okay, next one. -1 less than 3x minus 4 less than 14. So we need our number line to solve it. And since there are two of these symbols, we need to make a table. So I'll put less than there and less than there. So the first one, we're going to have -1 on this side, and then 3x minus 4 plus -4 on this side. Then on the other side, we're going to have 3x plus -4 and then 14. Now we solve. So x is here. It's got two numbers this time though. We got a times 3 and a plus -4. Please circle the times. It's positive, so we write K for keep. Okay? So we'll keep that sign the same, but I have to get there is a number I have to get to 0, so I put another one. So I plus 4 plus 4. -1 plus 4 is 3, and we have 3 times x. Then divide by 3. You have x after the symbol, and then 1. Please keep the x after the symbol if that's where it's at. Okay, then here, same thing, times 3 plus -4. So the times I want to circle, but I'll keep the sign because it's a positive 3. Okay, at the end. Now I do have a number I have to take to 0, so drop a sign, the same sign up here in between. So plus 4 plus 4, that takes us to 18. Okay, then I divide by 3, and I have x in front, 18 divided by 3, 6. So we got 1 and 6 again. Okay, circle, don't fill it, and then don't fill either one of your circles because they're not equal. Here it's opening towards x, so that'd be this way. Opening towards a number, back the other way. So x, you got 1, 6. Okay, open the sign to the 6, then open the sign to the x. Don't put the lines. Okay, next one. Yeah, I skipped a problem, didn't I? Okay. So anyway, okay, we'll keep going. I'll go back to the one I skipped. Negative 10 less than 3x plus 8 less than 41. Alright, so again, we need a table because we need to separate that into two different problems. So less than, gonna have negative 10 here, and then stop when you get to the other symbol. So 3x plus 8. Then you got 41 here, stop when you get to the other symbol, and you're going to put 3x plus 8 again. Then you solve them. So the wall, you have times and plus, so you want to circle the times. Put a K for keep because it's positive. If that was a negative 3, I'd put S for switch, okay? But positive 3, we're keeping it. Keep the same sign. Got to get your 8 to a 0 first. So you minus 8, minus 8. So negative 10 minus 8 is negative 18, and then 3 times x. Then I see times, I need to divide. So I've got x behind the symbol with negative 6 in front. Okay, over here, you got times and plus, so times, circle it, put K for keep. Okay, it means keep the sign the same, that's what that stands for. Get the 8 to a 0. Okay, so minus 8. Again, me lining that sign up down there is after I divide by the 3, but I do have the number I have to get to 0 first. So it's going to be 41 minus 8 is going to be 33. 3 times x. Then divide by 3. We have x. 33 divided by 3 is 11. So we have negative 6 and 11. Don't fill that one in, and don't fill that one in. So it's opening towards the x, even though it may be less than, it's opening towards the x or the variable. So this way, when it opens to the value, the number back the other way. So again, they combine. So you put negative 6, 11. When they combine, you open the sign to, remember, that's the biggest number, so the sign would obviously have to open towards it if it's the biggest number. That's the smallest number, so x is going to be bigger than that number every time, so then we open the sign to the x. Okay, then it looks a little different, but the process stays the same. We have 4x minus 3 greater than 11, or, okay, 4x minus 3 less than or equal to negative 11. Okay, you're going to need a table on this too, but you don't do the overlapping circles. You just basically copy the two things onto the table. 4x minus 3 greater than 11. 4x minus 3 less than or equal to negative 11. Okay, so make your wall. You have a multiplier of 4 and a minus 3. It'll be plus negative 3. Okay, put a K for keep. We'll keep the sign the same. We have to get the negative 3 to 0 before we divide, so I add 3. It's going to be 14, then 4 times x. Then I divide by 4. 14 divided by 4 is 3.5. Okay, then I got same thing, times 4 plus negative 3. Remember, it's positive 4, so you're going to keep the sign the same. Got to get your negative 3 to 0, so plus 3 plus 3. Negative 3, 11 plus 3 is negative 8. Then I divide by 4, and I have x, negative 2. Okay, so those are your numbers, 3.5, but now the graph's going to behave differently. You just have to follow your rules, okay, for what eating. Here it eats x with the 3.5, so if it eats x that way, with negative 2 it's eating the value, the number, so back the other way. So how do we label those? Well, I write or, and I put x separately, and then I just copy down what I got. Greater than 3.5, less than or equal to negative 2. Okay, with those you just copy what you ended up with. Okay, next one. 7 minus x less than 1, or 4x greater than or equal to 12. So again, your table. Okay, here's x. Well, there's only one number over there, and the operation's a minus, but plus negative, we need to put a 1 in front of the x, so it's a multiplier of -1. So we do have multiplication, and guess what? Okay, guess what? It is by a negative, okay? No, so I think I wrote that problem wrong. Okay. No, I didn't, okay? So that's a switch. You need to switch the sign, okay? But before you come down there, you have to get the 7 to a 0, okay? So when you're getting the number to 0, you keep the original sign. The sign returns down there. So get your 7 to a 0, -1 times x. 1 minus 7 is -6, then you divide by your -1, and you have x greater than 6. Over here, you just have times. That would be a keep because it's by a positive. And there's not a number out over on that side of the wall I have to get to 0, so I'm ready. I don't need the middle step. I just go straight to division. So I have x, 12 divided by 4 is 3. So we got 3 and 6. 6 and 3, whatever. Okay, the 6 you leave it empty. The 3 you fill it in. And you're eating the x with the 6, but you're eating the x with the 3. I did not do that right, okay? Okay, help a brother out here. The original problem, instead of saying greater than, should have said less than, okay? I screwed it up. I wrote a bad problem, okay? So if it's less than, it eats the value, so go back the other way. I'm not to change that, okay? So that's an or. So you just put x on each separate line, and you just write down what you ended up with. Again, I wrote a crappy problem. That's my fault. Yeah, next one's okay. Okay, we got 3x plus 2 less than negative. I will finish this video. I got to switch batteries on